Hi everyone, welcome to the Earth Science Regions Review podcast series created by Hommocks Middle School Earth Science Department. Today we're going to focus our attention on page 8 in the reference table, your geologic history chart. Now this entire chart incorporates the entire centerfold of your reference table, so make sure you watch my podcast on page 9 so you get a full understanding of this entire chart. Starting out in the far left, we're going to start out with some of the time units called eons to begin with. Before we jump into that, notice on the left side of the eon, you'll notice that there's a little bit of a time scale. And at the very top there, it says millions of years ago. If we start out at the very bottom, because you read these charts from bottom to top, that the number 4,600, that's actually millions of years. So 4,600 million years, that's 4.6 billion. 4,000 million years is 4 billion, 3 billion, 2 billion, until you go all the way to the top of the chart, which is current time. Now eons are the biggest units of time. The oldest and biggest unit of time of our eons is going to be the Precambrian. Precambrian actually incorporates about 85% of our history. Even though it incorporates the biggest chunk of history, we actually know very little about it for two reasons. First off, the rock during the Precambrian time has been eroded and weathered and really has undergone such dramatic changes. We have very little Precambrian rock that really tells a little bit of a story about the type of life that lived during the Precambrian time. Second off, any of the organisms that lived there during the Precambrian, a lot of them were soft-bodied organisms. They didn't fossilize very well in the rock. So Precambrian is such a big unit of time, it's actually broken up to two sub-eons called the Archean and the Proterozoic. Above the Precambrian, we have what's called the Phanerozoic, and that's the eon that we currently live in. So to kind of get an idea about what was going on during the Precambrian, okay, the earliest part of the Precambrian is called the Archean. And you'll notice it extends all the way to the beginning portion of our planet, 4.6 billion years ago, estimated time and origin of the Earth, oldest known rocks, evidence of biological carbon, all the way up to about the middle Precambrian, in which oceanic oxygen produced by cyanobacteria was starting to form. Mid to late Precambrian, which we call the Proterozoic, the big thing here is that oceanic oxygen begins to enter the atmosphere and organisms start to reproduce sexually. Now the thing is, you notice that there's a major boundary between the Precambrian and the Phanerozoic. There's two reasons for that. Oxygen and the fact that animals began to reproduce sexually, big change within the evolution of our species. Above the Precambrian, that's our Phanerozoic. And the majority of this chart can be squeezed into that little tiny section called the Phanerozoic, which began about 550 million years ago. Well, eons can be broken up into a smaller time unit called an era. Now, when we extend down to the bottom of the chart, you'll notice that your Precambrian is also an era as well. That's not as important as the Phanerozoic eras, which include the Paleozoic, the Mesozoic, and the more recent Cenozoic. Now, your eras can be broken up into even smaller time units called periods. These are probably going to be the most important time unit that you can be tested on your readings exams. So make sure you have an idea about them. And you'll see that there's a wide variety of them all throughout history. So very important that you understand the names of these and what periods belong to what eras. Starting at the bottom, we have the Precambrian, which is an eon, it's an era, it's also a period. Then we jump into our Paleozoic periods, which are the Cambrian, Ordovician, Silurian, Devonian, Carboniferous, and Permian. We then have our Mesozoic periods of the Triassic, Jurassic, and Cretaceous, and the Cenozoic periods of the Paleogene, Neogene, and Quaternary. Now our periods can be broken up into even smaller time unit called an epoch. Now most of our epochs are going to be identified as early, middle, and late. A little bit more of a generalized unit here, very simply because a lot of our periods go back way well into our history, 400 or 500 million years ago. So very hard to get exact specific values for our epochs. So you'll see the majority of our epochs are just use general terms such as early, middle, and late regarding the epochs, with the exception of the Cenozoic periods. So if you look at the Quaternary period, this Quaternary period is broken up into two epochs, the Pleistocene and the Holocene. The Neogene period is broken up into the Miocene and the Pliocene, and the Paleogene is broken up into the Paleocene, Eocene, and Oligocene. Now the reason why we can actually give names to these epochs, because if you look back Okay, the beginning of the Cenozoic began about 65.5 million years ago. That's relatively young, and we have a little bit more understanding about our history because it's more recent. So we can actually break up our periods into epochs that literally have names to them. Next to the epochs, you'll see that you have another time scale, okay, that extends from 1.3 billion at the bottom all the way up to 0, which is current time. This time scale is actually a little bit more specific than the one to the far left next to your eons, because this one actually gives you the beginning and ending values for each one of your time units. Whether it's the eons, whether it's the eras, the periods, or the epochs, you can actually determine how long each individual time unit lasted. So to give you a little bit of a clue here, if you take a look at the Jurassic period, for instance, the Jurassic period began 200 million years ago, because again, you read this chart from bottom to top, so the bottom number is going to tell you when the time period began. The top number of that box, and you see that the Jurassic is kind of in a little rectangle box there, you'll see that the Jurassic ended 146 million years ago. You subtract those two times, the Jurassic period lasted for 46 million years. And you can do that for any time unit here, eons, eras, periods, or epochs. Next to your epoch, you have life on Earth. The big thing about this section is just being patient. There's a lot of information in here, and it's actually extremely easy to read as long as you know where you're looking for your information. Let me give you a couple examples. If you're asked to find out what epoch and period did earliest trilobites live, you find earliest trilobites, just bring it right across the left. Whatever epoch it hits, in this case early, and whatever period it hits, Cambrian, is going to give you the time unit that you're looking for. Earliest trilobites, okay, early Cambrian. Take a look at earliest insects, late Silurian. Abundant reptiles, early Permian. Abundant dinosaurs and ammonoids, middle Jurassic. Mass extinction of dinosaurs, ammonoids, and many land plants, that's going to be the end of the Cretaceous. Take a look at humans, mastodons, mammoths are going to occur during the Pleistocene epoch or the Quaternary period. You could have even extended that well into your eras as well. The last piece of information on page 8 in your reference table is going to be your New York rock record. And you'll see that there's a little key at the top here. A little symbol for sediments, a little symbol for bedrock. Starting at the very bottom, you'll notice that there is a line here, black line. In some cases it's completely intact. Other times there's little gaps and little breaks in them. That's going to indicate you have some erosion going on. When you watch my podcast on page 9, we'll explain to you a little bit why there's certain erosion in certain locations. But if you look at the Precambrian, there's not a complete rock record there. You have a big gap there. Big gap in the rock record, that's what we call an unconformity. Take a look at the Cambrian, Ordovician, Silurian, and Devonian, complete rock record. There's no break in the black bar. Take a look at the Mississippian, there is a break, so you're going to have an unconformity. The Pennsylvanian, it's incomplete. You're going to have an unconformity. The Permian, there's no rock at all, completely wiped out. Triassic, partially there, but very incomplete. Same thing with the Jurassic, partially there, but somewhat incomplete. The Cretaceous, we start getting into a little bit more of the sediment, but again, you notice that sediment is partially incomplete, so you're looking at unconformities here. Paleogene, completely gone. Neogene, completely gone. And if the Quaternary ended today, you would have a complete rock record once that sediment lithified into sedimentary rock. So with that being said, that's it for page 8. Make sure you take a look at page 9, and I have a couple other podcasts that incorporate this specific chart, so make sure you check them out as well. We'll talk to you soon.